Okay, so the welcome to this develop schedule session. So develop schedule is what we are going to do it to analyze an activity sequence, duration, a resource requirement, and schedule constraint to create a project schedule. So here, what you are going to do is basically you are making a schedule of whole project. You are developing the schedule. Okay, so here we are going to analyze the activity sequence, whatever we have already done the sequence activities in the previous slides, and so analyze the activity sequence and whatever the duration. That's so part of the estimate activity duration that we have done it. Estimate what are the resources are required and schedule constraint to create a project schedule. So here in this process, we're going to basically create the project schedule. Okay, for so on a higher level, on a very detailed way. So this is called as a develop schedule process. Very important topic from this project time management. So what are the inputs will be there? You'll have the inputs like a schedule management plan, activity list, activity attributes. So these are important. From when you're developing a schedule, you should have a plan for that. So this is a schedule management provides a plan for the plan for it. So activity list, the list of the activity that you want to do it in the project. So this is activity list. Activity attributes, again, each and every activity, the detailed way, every activity that needs to be defined. So that is, I have already explained how what are the things will be there in the activity attributes. So attributes will be there. Then a project schedule network diagram. So network diagram, where. So let's come to this, those things again. So what is the activity list? So this is a list of your activities. Okay. So basically you can see this ID and activity and this description. So here it will be the list of the activities in the project that you are going to do it. So this is a activity list which is required when developing the schedule. So this is one thing. Then what is the activity attribute? So activity attribute is like this part. Each and every activity is described in a very detailed way, so that you know what is the expected output, what are the skill requirement, what are the resources required. So you can develop the schedule in a very detailed way, in proper way. So that's why activity attributes give you those detail. So these are the information is there, like a predecessor, a relationship, what a relationship between there. Is there any lead and lags is there? What is the successor activity that you are going to do it, and what relationship it and what a lead and lag time is that. For a skill requirement, what requirement you want to need it basically on a skill perspective to complete this task, number and type of resources required. So all this information is mentioned in the activity attributes. So you'll have there's one more thing that in this that was a project schedule network diagram. So it is which will get an output. So okay, so network diagram is look like this thing. Okay, so this is how your network diagram will look like. So you'll put it in the activities, and then you'll basically plan it in such way that which activities dependent on which activities, other activities. So you like activity C, you can see that dependent on the activity B, and activity A. So activity D is just dependent on activity B. So this is called a network schedule diagram. So these are the input which you need it when you're developing the schedule. So for develop a schedule, these are the things that you need it. Resource calendar, the calendars of the resources in terms of where resources are available and what are the resources are there. Activity duration estimate. So this will give you that for each and every activity when it gets completed. So the time duration, because that's important. You're developing a schedule, you should know each and every activities which you have already done as part of the estimate activity duration. Okay, so that is where you'll get this activity duration estimate. Okay, then you'll have a project scope statement on a higher level, because when you're developing a schedule for a project, so you should know what is the project scope statement. And risk register, list of the risk which will be there in the project. So this will help you to develop the schedule, and so you understand what are the risks and what are the mitigation plan. Do you have it? And then that is basically when developing the schedule, all those things are needed. Project staff assignment. So how the resources have been assigned. So if you have that plan, so that this will help you to plan your schedule. Resource breakdown structure, on which task, on which activity, what are the resources available, when they will be, what are the resources are you need it, and when they will be available. So that's part of the resource breakdown structure. Enterprise environmental factor, when you're developing a schedule, this is a very important factor that you need to consider it. What factor can affect your project? Organizational process asset. So in terms of what are the repository data resources that you have it, basically that can affect your project. So these are the things that is input, and this is basically these are the input of the develop schedule. So what are the tools and techniques that you are going to apply it? One is that schedule network analysis. So that I've shown you that network, right? So network diagram. So you're going to analyze those things. You're going to understand, and so it's just like this network diagram which I have shown you earlier. So this is a network diagram. So it's just a schedule network analysis. You're going to do analysis of this, these network diagram, and then you will come to know what will be the overall plan for that. Okay, so project schedule is there. So this is one way of doing it. Another way is like this is a critical path method, which we're going to cover in the coming slide. Very important topic from the examination perspective, from this chapter perspective. So it's a very important topic. And the critical change method, which is dependent on the critical path method. So we're going to cover it in the next slide. And the resource optimization technique. Okay, so these tools and techniques we're going to discuss it. Let's discuss about what is the output that we're going to get it out of this develop schedule process. So what output you will get it? That's a schedule baseline. Project is schedule. So schedule baseline is on on each and every phases. What are the deadlines are there? So that's called a schedule baseline is there. And the project schedule, at the end you will have a project schedule. That's one thing. Schedule data, you know that okay, what for phase 1, phase 2, phase 3 when it will complete. So you have a schedule data. It's all about a project schedule. Project calendar. Now you know the when the project can completed, and what is the each and every phase when it get completed. So you have a project calendar for that. Okay, and project management plan updates. Now you can update your plan based on the schedule that you have created. So you can update your plan, and project document updates. You can update your project document. So these are the things basically the output. You'll get it out of the develop schedule. But to get this output, what tools and techniques that you're going to apply it, you're going to on those input. So that's like this critical part of the critical channel. So these are the tools and techniques will be there. So let's discuss schedule network analysis that we have. I have already shown you what are the schedule network analysis like. What you are going to do it. That's a milestone chart or bar chart or project schedule network diagram. So you're going to analyze those things, and you're going to come to know that this is a project schedule. Okay. So the project schedule can be presented in the graphically into these three things. So this is a milestone chart in like a graphical way. Okay. This is the project start date, and this is the project end date, and maybe like on a design when it gets completed. So this is on a project management perspective is very important. This gives you that okay, when design will get completed, when the requirements will get completed. So this is a milestone chart, and this project schedule can be displayed in the milestone chart, and then you can have a bar chart also. Okay, so each and every activity, how much time it will going to take it, and when it will get completed. So bar chart is one way of representing a project schedule. Project schedule network diagram. This is a network diagram I was talking about. So this is one way of representing your project schedule. Like this is a start date, these are the activities are involved, and this is end. So you know that okay, when the project gets completed. So based on the time take, and when the project gets started, what will the duration it will take, and when it will get completed. So this is you can come to that. You can make this a project schedule. So from this network diagram. So this is one way of representing a project schedule. So you will have a schedule baseline, as I mentioned earlier. So higher level when it gets completed. And schedule data. Schedule data is like something project document updates, activity resource requirement, activity attributes, calendar, risk. So these are your schedule data is there. Okay. So develop schedule output. So in that case, which I have already discussed about the collection of information for describing and controlling schedule. So that's not the important thing. So let's come to this, the critical path method, which is a very important topic from this tools and technique perspective of this develop schedule. Okay. So how this critical path method is get calculated? So critical path method. So now if you see this, two things you need to understand. One is called as a forward calculation, other is called as a backward calculation. Okay. So in the exam, they will give you this activity A, when it gets started, what will the duration it took to complete it. Okay. So for example, in the exam, normally they give this scenario like this. They will give this like this: activity, predecessor activities, and duration. So based on this, they will give the scenarios like this thing, and based on this, you need to make this diagram. Like this is activity A, for example, like this thing. You need to do like this thing. Okay. You have to plan. You have to make a diagram like this thing. So you will get an option. You will get a diagram like this thing. Okay. They will give you something like this, or sometimes they give you scenarios only. Then you make a table out of that, and then you need to make a diagram. Okay. So you make a table, then you make this diagram. Okay. So just very similar to that. Okay. So so they will give you like activity A, and it took 3 days to complete it. Then activity B, and this predecessor of activity B is A, and that it takes 4 days to complete a B. So they give you scenario. You can, by reading, you can understand. Okay. When you make this, do the rough diagram and just make this diagram look like. Okay. And so let's take the previous previous example, and then we'll calculate it. So now, after you understand the scenario, make this diagram. Okay, activity A dependent on the. So first thing, just make it like activity A. What are the dependencies are there? Okay. Then mention a duration on top of that. Okay. So this will help you to calculate the critical path method. Okay. So and so you mentioned, okay, these are the duration will be there. Okay. Now you need to calculate. So this is important that they don't give you. So like they will give the start date. Okay. They will give you start date, earliest start date, and earliest finish date of the activity B, or few of them. And then you need to calculate the earliest start date and earliest finish date of each and every activity based on this network diagram. How you can calculate it? See this, the example, this activity A, it is started on which day? That is first day. Okay. What is the duration it took? It will be going to take 10 days to complete this activity A. So on 10th date, it will get completed, right? So that is how. This is earliest start date it can start it, and earliest finish date. Earliest finish latest, not later, earliest it can finish this task. That's called as 10th days it will get completed. That's the one thing. First thing, let's do the forward calculation. Okay. Then we'll come to the this backward calculation. So let's see this. This what you can say, green one, right? So green one is we are doing a forward calculation, and then backward is the blue one. We're going to do a backward calculation. So now you have this earliest start date plus duration minus 1. So what you are going to 1 plus 10 become 11. 11 minus 1 become 10. So you will get this is the earliest finish date. Okay. So that's what I understand the logic. So here, what I'm going to do, so let's take the diagram. Here we have a critical path method. Okay. So what we are doing it. See, activity A. So I'm doing a further. So 1 plus 10 minus 1, that's become 10. So that is what the 10th day. So that's why here you have a 10th. Okay. And then if you see this, I'm doing now when it gets completed, activity A will get completed on 10th of activity A will get completed on 10th of particular days. The next F, activity A is linked to the 3 activities. One is activity F, B, and H. Okay, it is basically linked to 3 activities. Now this 10, this activity is completed on 10 days, but other activities they can start on 11, right? They can't start at 9, they can't start 10 because activity A will get completed only on 10th. Okay, so next can be started on, that is a F, B, H, that can be started on A. So the earliest start date for activity F is 11th, right? Because this is when you can start it. That's 11th here, 11 here, now 11. You know the duration of each and every activity, the duration they will give you, as I will show you in the diagram. They will give you the duration. So you know that for which activity, what duration will be that. And you know which one is the previous activities of that. So because of that, then you can make a diagram, okay? So now, let's this. So you know the duration. Now you know the earliest start date, that's 11, plus duration, that's why you are going to apply 15. 11 plus 15, 26 minus 11. So that's what the forward calculation I'm doing. That's the earliest start date plus duration minus 1. So let's come to the logic. So here, what I'm going to do, so activity B. So see, activity B is when it gets completed. So on activity B, that's B, right? 10 plus 20. 10 plus, 11 plus 20 minus 1, that will become 30. That's why you will get a earliest finish date. Okay. This is called, the first one is called a start date. This one is called a finish date. Okay. So this, okay. So this one is called as a, start date, and this one is called earliest start date, and this is called the earliest finish date. Okay. So so now you got a 10. So earliest start date of this activity B is only 11, because that's the 10th on 10th. So now you want to calculate earliest finish date. So this is, then what will be logic? That is 10, 11 plus 20 minus 1. So that's become 30. So this is how the logic is that. Okay. B, 11 plus 20 minus 1. So calculate C. So now if you want to calculate C, this B will get completed when? That is on 30th. C can be started only on 31st only. Okay. Because C is so you can start it on 31st. So now let's do that. So 30 plus 31st. So if you see this, calculation, 31st plus 5 minus 1. So it's become earliest finish date for C is 35. So that's why it is a 30. It's a not a 35, it's a 36, right? 35 plus 5. Yeah, 36. 36 minus 1. This is 35. So I think, hold on. So here it should be 35. Actually, I've done a mistake here. So it should be the 35. Okay, because in this diagram. Okay. So 31 plus 5, 36, 36 minus 1, that's a 35. It should be a 35, okay? So, just I will make a correction, on the other diagram. But for a time being, just understand, okay? So this will be your 35. And now, what will happen here? You have, when it is, that's why if you see this, this is a 35. Then next one, that is what, that's a D. D can be started. This is it will get completed on 35. Then this can be started on 36 after 1 day, right? That's why this D is right. D is a 36. So D can be started on 36, and it took 10 days. That's the logic is that, okay? 36 plus 10 minus 1 will become 45. So earliest finish. Then for E, let's do the calculation E. E is what? Here if you see this, it will get completed on 45 days. So next E can be started only on 46 days. 46 plus 20, thus you will get the 66 minus 1, thus you will get 66. So that's where you can calculate the E, right? So that's where you can calculate it. So now you calculate A, B, C, D. So you calculate all these tasks, okay? Now let's come to this AF. You want to calculate the activity, earliest start date and earliest finish date for activity F, G, and H. Okay. Now F is the predecessor of F is A. So A, when it is completed, it is completing on 10th of that. Okay. But so this one can be started on 11th of that. So on 11th day, F can be started. The duration it took 15 days. So 11 plus 15 minus 1 become 25. So that is where you see this F will be 11 plus 15 minus 1, that's become 25. Let's calculate G. Now G is basically getting an input from C as well as F. See understand this thing. Even though G, G cannot be started on 26. Reason, because it is dependent on both. It is it is dependent on both. That's the F and C. So earliest G can be started from. That's G can be started after C can be completed. So C, because C will going to take more time. C is taking 35 days. Here it will be 35 days. Okay, instead of 36. That's a correction. It should be. Hold on. I can use correction of this. Here it will be 35 days, okay? And again here it is. I'm talking about this one, okay? This part. Okay, so perfect. So now it is a 35 days. This is again 35 days. So both is 35. Now, so C is getting completed on 35. G can only start it on 36 only, because that is what, because it dependent on C. It can't start it on 26. The reason is because it is dependent on C also. C is taking more time. So earliest start date, G can be started only after C is get completed. That's where it is starting on 36 days. So now F has a buffer time here. Can you see this? F has some buffer time. So that's called as a free float. We're going to discuss about it. Because here even F activity can be delayed for 10 days. 10 and 11 days there will be no issues, because G can't be started, right? So that's called a free float. We're going to discuss about it. Okay. So G is, you calculate 36 plus 5, that's 36 by 41 minus 1, that's 40. So again come to the H. So H is again, it is dependent on A only. So A is get completed on 10th. I can start a H on 11th only. 11 plus 15. So that will become a 26 minus 1, become 25. So again here, see E. E is here, it is completed on 25th, but E can't be started because here D is taking more time, because the maximum there's a 45 days. So this E can be started only after D is completed. Like that's I can start it only 46. Okay, I can't start it on 26. I can't start it 41 because E is also dependent on D, and D is taking more time. So the maximum will, so the E can be earliest started. Earliest start date of E is 46. So this is called as a forward calculation. Okay. So we have done, we should do the calculation. We should do the calculation this way. So first thing, and one more thing, in the PMP exam, based on this diagram, you will get 3-4 questions. So spend time on that. Okay. Don't worry. Spend time on this particular making this diagram, because you can answer a 4 question based out of these diagrams. So but if you make this diagram incorrect, then you will unfortunately other question will be wrong. Okay, so this is important. Now let's do the backward calculation. That's you're going to calculate the latest start and latest finish date. So this is a blue one. Okay, so we're going to calculate. We'll go from, instead of A, we're going to start from E. Okay, so E, what is the, on 65 days it will get completed. Latest start, so it will become 65 days. So now do the backward calculation. So 65 minus 20 plus 1. So that is latest start date of E. That's because you can calculate 65 minus 20 plus 1. So that is the formula for backward calculation. Okay. So let's take this diagram. Okay. Now what I'm trying to say. Okay. So you know this, right? you have E. E is have 65 minus 1. So see the backward calculation, that's what I'm trying to do. 65 minus 20 plus 1. This is the formula. Okay, so for calculation, so you know you can calculate the latest, latest start date. Okay, this is the 46. Now E is dependent on G, D, and H. Now see, this is get completed on 46. I can start G on 45 only, D also on 45, H also on 45. Okay, I'm talking about latest finish date of this D can be 45, 45, 45. The reason, this is the latest start date of E. So this is a 46. So this will be the 45. This will be 45. This will be 45. Now let's calculate the latest start date of G. Okay, so latest start date of G, I can calculate it. So what will be the latest start of G? 45 minus 5 plus 1. Why? Because 45 is this one minus duration plus 1. So it's become how much? You will get that's a 41. 45 minus 5 plus 1. That's you will get a 41. Calculate D. Okay, 45 minus 10 plus 1. You will get a 36. 45 minus 15 plus 1. You will get a 31. Right? Calculate. So you calculate G, D, and H. Now calculate C. This is 36. So latest finish date of C is 35. That's why I'm making the diagram. This is 35. Okay. So 36 is a correction, is that okay? So this is 35. Now 35. What was the duration? Duration is 5. Okay. So sorry. So your duration. So the 36 minus 5 plus 1. So 36 minus 5, 30 plus 1. So the latest start date of C is 31. Then if it is 31, B is, what will it be? That will be 30. 30 minus 20, that will become 11. If it is 11, then latest finish date of A is 10. 10 minus 10 plus 1, that's 1. That's the reason. Now you calculate this thing. Same thing you can calculate this one. 41. So this become a latest finish date of F, 40. 40 plus minus 15 plus 1, that's become 26. 45 minus 15 plus 1, that's a 41. So this is, now you got a whole this thing. This is earliest start date, earliest finish date. Latest finish date, latest start date. So you have earliest start, earliest finish. Latest start, latest finish. Now the formula for a critical path method. What is the critical path method? Critical path method, that's the, like a minus earliest start date minus earliest finish, or earliest finish date minus earliest start date is 0. Earliest finish date minus earliest finish date is 0. So what is the critical path method formula? Critical path method is a longer duration of the project is what is the latest start minus earliest start, or latest finish date minus earliest finish. So is earliest finish date. So this is also should come a 0. See the logic. Now latest start minus earliest start. So see this. What is latest start? That is 1 for A. What is earliest start? 1. 1 minus 1, 0. Okay. So this is, and the formula is one more formula. That's the same thing. Latest finish is both. It should be both. Latest finish minus earliest finish. So this latest finish 10 minus 10. Again it's 0. 10 minus 10 is 0. C 11 minus 11, 0. 30 minus 30, 0. C 31 minus 31, 0. 35 minus 35, 0. 36 minus 36. So you are getting that all these things needs to be completed on a tight schedule. So here you don't have a much buffer, because earliest start can be this thing and latest start can be this thing. Earliest finish be like same and latest finish is same. So the difference between these two is whenever a 0, this path is called as a critical path method. This red line, A, B, C, D, in E. this is the longest duration of the project. Longest duration of the project because you have a lot of duration like a 10, 20, 5 plus 10. So what is the number of days required to complete it to reach E? 10 plus 20, 30, 30, 35, 45, and this is 65. So this is the longest duration of project because, and here there is no buffer available between these, these tasks. So this is called as a critical path method. Okay. So this is the way you're going to calculate it. They will ask you in this network diagram which activities will become a critical path method. So the activity A, B, C, D, E is become a critical path method. Okay, so this is one thing for calculating this critical path method. Okay, so hey, Uday, did you have? Are you clear about this? Any doubt?
Yeah.
Perfect. So now next thing is that a critical path analysis. So hold on. Okay, so we'll come to the critical path method. So you understand what is the critical path. Okay, so you're going to analyze and then you'll see, and based on that we'll come to know that the free float. We're going to calculate what is the free float, what is the total float, and project float. Okay. So perfect. Now, so what are the types of floats are there? So the float is, you have three types of floats are there in this this network diagram. One is called a free float, total float, and project float. I will give you the simple example. This description is total. Total float time is a single activity can be delayed without affecting earliest start of any successive activity. So they will ask you what is the total free float and total free float and total float. So take this diagram and we'll explain you what is a free float and what is a total float. Okay. This is let's first thing calculate a total float. Total float is now. Okay. So what is the formula for a free float? Free float is a simple formula to calculate a free float of current activity. Free float of a current activity, that is a earliest start of successor activity minus earliest finish of a current activity. So come to this diagram. Whenever they ask you, give me the free float of activity F. Let's start activity F. Okay. What is the free float of activity F? So what is it? They have formula is a formula is what is? That's the earliest start of successor. So here earliest start of successor. So earliest start of successor. F successor is G. What is the successor? Earliest start? Earliest start is 36. Right. So earliest start of successor. So that's a G. Okay. And that is what that value is 36. Right. And earliest finish date EF. That's the earliest finish date. Finish date of a current activity, and we are current activity, and that we are calculating is the F. Okay. So now earliest start of successor 36 earliest, and that is what the formula is. Earliest finish date of current activity, that is 35. Okay. So here you have this is 36 and this is the earliest finish date of this year, that's 25. Okay. So this is 25. And what is the free float? Free float is same thing. Okay. 36 minus 25. That's become 11 days. So this is what a free float is there. Free float of activity F. So what is the activity of? So what it means that, okay, if what do you know free float? See this, the definition is that single activity can be delayed without affecting earlier start of any successor activities. So even though activity F is delayed by 11 days, there will be no issues on activity G, right? Because G will be start only after 36, only on 36, right? Even though G will get complete on 26 or 27, 30, so there will be no issues if it is delayed by 11 days. That is called as a free float for this activity F. But on a critical path method, you will not get a free float. Free float, you will get a 0 because C, C 31st and this is 30, because here if you see this, you can't delay it because here you have to start on 30, next day is 31, right? So on a free float, you don't get a free float on a critical path method. Okay, that's why. But on other thing, you will get a, here activity F have a free float, right? So like you can see that the free float of H. Okay, so let's calculate the free float of H. Free float of activity what is the successor activities? What is the earliest start date of successor? That's the 46. 46 minus earliest finish date. That's the earliest finish date of current activity. That's the 25. 25. So now you can calculate that will be the 26, right? It's a 21. So the yet can be delayed for 21 days. There will be no issues on that. Okay, so this is called a free float. Then another is called as the total float. So let's come to the total float. What is the formula for total float? Total float of current activity is the latest start minus earliest start. Latest finish minus very simple. Latest finish is the earliest finish simple. It's a very simple, like this one. Latest latest start minus earliest start. 31 minus 11. 46 minus 25. So that's how you can calculate the total float. Okay. Okay. So this is all about the critical path method. So you just take a break. 1 second.